In this video, we will be discussing the theory of constraints. From what we've experienced in our work with Lean and Lean Six Sigma, companies often struggle to prioritize. It is a constant challenge to answer the question, where do I place my efforts? The theory of constraints is, in my opinion, one of the better tools for organizations and teams to figure out their prioritization efforts. It was originally described by Mr. Goldratt back in 1984 in his book, The Goal. In essence, what the theory of constraints talks about is finding and working on the bottleneck. Imagine being in a manufacturing environment and wanting to achieve a faster delivery to the customer. After all, if we deliver faster, we can send out our invoices faster and generate our income faster. Now, in such a case, the throughput is central. Take a process with 5 steps, as illustrated here. And in every one of these steps produces a certain amount of units per hour. Let's say step 1 produces 4 units, step 2 produces 2 units, step 3 produces 5 units, all per hour, etc. Now let me ask, how many completed units can this whole process actually produce in 1 hour? Logically, the answer is 2, because of the bottleneck. So we have to look at what is going on in this process. If the first step is producing 4 or 5 units, the result is that step 2 will have what is called work in progress. You'll see chaos and stress because in this case, step 2 is unable to keep up. Work is piling up, as the previous step is producing units more rapidly. But it could also be an indication that there is a lot of work being sent back from step 3 to step 2. Possibly because work in step number 2 has to be completed very quickly, pressure might be creating defects, leading to work being sent back. Work in progress can be caused by both the previous and the following steps. Now note that this doesn't necessarily have to be a person. You can also encounter this in a hospital. When you are looking at a waiting room filled with patients, that's a bottleneck. Or when you look at a business process and you see papers piling up on a desk, that could also be a bottleneck. And if you think about a manufacturing environment, if you see many pallets beginning to stack up, just waiting to be assembled, that could also be a bottleneck. You can encounter bottlenecks like this even in your home. For example, if potatoes take the longest to prepare while other ingredients have to sit there waiting for them, then that's the bottleneck in our dinner. In essence, the throughput of a process is determined by the bottleneck. Now, if we look back at organizations and how this relates to them, you have to look at how organizations are, organized. They tend to have a number of individual departments, which all have their own key performance indicators. It's logical that they embark on their own improvement projects. So, for example, if number 5 were to say, I want to improve my own efficiency, meaning departmental efficiency, and I want to go from 6 units per hour to 9, you have to ask, would that have an impact for the customer? In this case, it doesn't, because the speed of delivery to the customer is determined by the bottleneck. It is a very limited efficiency to start improving things unrelated to the bottleneck. So how do we go about improving a process? Well, we have 5 actions we need to undertake. First, we have to identify the bottleneck. Where is this located? Secondly, this process, which is the bottleneck, must never stop. And what that means is you never want to slow down this step, number 2 in this case, where the bottleneck is located. Because slowing down means you produce even less and deliver even less to the customer. So the bottleneck process may never stop or slow down. If the bottleneck stops, the whole process stops. The third step of the theory of constraints is to adjust the speed of all the other process steps to the speed of the bottleneck, so that there is no unnecessary work in progress or waiting time created. Fourth, you work to improve the speed of the bottleneck itself. The bottleneck needs to be as lean as possible, relieved of all excess baggage. You could improve the output of the bottleneck by using some of the resources from the other steps or departments which have overcapacity compared to the bottleneck. And fifth, you go back to the beginning, to action number 1, identifying the new bottleneck. Why? Because once you have made your improvements and are seeing results, it is highly likely that there will be a new bottleneck. This process is cyclical.